primary school math problem, and it's hard.
It's primary school one, huh?
Yes.
Is it in English or Chinese?
Chinese.
Oh no. Can you explain it to me?
Yes.
Do you have the answer? Do you have the answer yet or not?
No.
Oh, whoa. Okay. So go ahead. Let me write this down. I also may not be able to do it. That's a problem sometimes. Okay. Let me try this with you. Okay, go ahead. What's the problem?
So a guy used matches to build a square. He built a 2x2 square using 12 matches. He built a 3x3 square using 24 matches. He used 1,300 matches to build a n by n square. So how much is n?
Oh, okay. That makes sense. But wait, so he used 2x2 squares using 12 matches, right?
Yes.
And you said 3x3 was 24?
Yes.
Okay. And then what was the final one?
1,300 matches.
How much squares did he do?
N by n.
Yeah, what's the n by n? Yeah, n by n. So n by n equals what? N times n equals. Yeah, so that's. Oh, so but do you think that if it were 2x2 is 12, 3x3 24, do you think 4x4 is 36?
I don't think so.
No, I don't think so either. But I'm trying to picture 2x2 using 12 matches. Hold on. 2x2 square. And that took 24 ones. Let me just count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Yeah, I can see how that's 12. And then 3x3. So every time you extend it, you're extending 1, 2, 3. Wait, that's 3x3. 3. And down as well. So you have to work out that there's a formula, isn't there? There's an extra. Oh, that's interesting. So there's an extra 1, 2. How many? So the difference, it's 12. It must be 12. But if you did it again by 4x4, then it would be an extra 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Ooh, that is tough. So what do we divide n by? I'm sure you can work it out. If you think about, if you half that, it'd be 1 by 1, which would be 6. And then you divide that by 3, it's 8. So yeah, 4 would be, wait, you go 6, 8, 10. Okay. Right, it's a difference. Oh, this is interesting. This is a fun one. Yeah. So how are you working this out right now? I think I've got some kind of system. Like if you were to half it, a 1 by 1 square would use how many? 1, 2, 3, 4. It would just use 4, right?
Yes.
So there is a pattern here, 4, 12, 24. So it's like, it's not logarithmic. There's a thing that we use here. 4, 12, 24. The difference is 6 and 2, 8, 10. Yeah, 6, 8, 10, 12. So then all you need to do is, if this is 2, 3, it's the 13th. 3, no, 10, 11, 12, 13. 130, is it? 130th iteration. So you need to carry on this number 2, 4, 6, 8, 10 to 130. So this is number 2. 3, 4, 130. 130. 1 be 4. 130. Hold up, where's my phone? Ooh. Also, do you think it's a whole number, right? It's not going to be like a fraction, obviously. It's not going to be a half matchstick. Yeah, for sure. Like 10, 11, 12, 13. It's 130. So like I was thinking 1,300 matches would be the third 130th iteration of the pan. So damn, that's hard. Yeah, I can't do it either. I'd have to keep working at it. It's tough. It's fun though. I feel like I'll share the screen that I've got with you. Like maybe this can help you work it out. So for example, my thinking is that for, if it's a 1 by 1 square, it uses 4, right? A 2 by 2 uses 12. So this is times 1, times 2. Sorry. Times 3 would be 24. Times 4 would be, well, we don't know. But if we look, we can see that there is a pan between these numbers already. So the difference here is, what is it, 8 and then 10. So I'm thinking maybe the difference here might be 12. And it goes up like that. Have you worked that out?
Yes.
Is it 36? It's not though, or is? Does it not work? If you did a 4 by 4 right now, so 1, 2, 3, 4, 8, 12, 16, and then you've got 1, 2, 3, 4. Yeah, right. So now there's an extra one. So just the perimeter would be 16, nice and easy. You got another 4, 20, 24. Wait, 20, 24, 28, 32, 36. Isn't it 40 now? 40. Isn't that 40? 16 is an hour plus. Oh no, because wait, how many is it? Wait. 4. Yeah, 20, 24, 28, 32, 36, 40, right? It'd be 40 for a 4 times 4. A 4 times 4 would be 40, right? Is that right? Or not?
No.
It's not right? Because there's 4 here, 4 here, 4 here, 4 here. That's 16. How many is a 4 by 4? How many is a 4 by 4?
14.
It is 40, right?
Right.
Yeah, right. So that gives us more information. So we thought originally that it was going to be 36 if it's following the 8, 10, 12, but it's not. It's following a different rule now. So we have more information to point to the code for you. So now we know that there's probably like an algebraic equation involved. Something like, n plus or n times or something, right? Because this is now 40. So now we see the difference is 8, 10, 16.
Yes.
Right. So, okay. So then what's the difference between these guys? It's those 2, 6. The difference of 4. 6, 10, 12.
Oh wait, if you divide the numbers in the right, the first should be 4, the second should be 6, and the third should be 8.
Right. The first numbers, what do you mean?
You can use 4 divided by 1.
4 divided by 1 is 4.
And 12 divided by 2
equals 6.
Yes.
3 divided by 4 equals 8. Oh yeah, that's another way. 4 divided by 4 is 10. So wouldn't it be like 130 divided by something? Right? Or 1300 divided by something. But the reason I said 130, well, we can do, it's just that this is the third iteration. This is the second, this is the third. 1300 would actually only be 130th iteration, but okay. So it should be, okay, hold up. So 24 gives us 8. 3 times 8, 3 times 4. Wait, what if you add the numbers together, like the 6? Like 2 plus 2 is 4, 3 plus 3 is 6. This also goes into 24. 6, 12, 18. 6, 12, 18, 24. That goes in 4 times. Like this one goes in 4 times. And then 4 by 4 would be 8. And that goes in 4 by 4. 10 times. Huh. Times 5 by 3. 6. Wait, we have so you can add them. There seems like there's a pattern here, right? Like, look, you add these together. So 2 plus 2 equals 4. And it's 4 times 3. Add these together gives us 6. And it's 6 times 4. Add these together gives us 8. And it's 8 times 5. So theoretically, there should be 10 times 6. It should be 60.
Yes.
Is it 60 for 5 times 5?
Yes.
So we found it. You add the number. So all it is, but now.
So that should be,
this is the 130th iteration. So it's always half. So what's half of 130?
650.
Yeah, 650, but maybe 65. I feel like it might be 65 rather than 650 because it can't be 650. like this is the third iteration of this pattern. So like this is the, I don't know if it's not the 1300 iteration, right? It'd be the 130th iteration, I feel. I could be wrong. Why do I feel that's wrong? So you think it's 650? Then that can't be right though.
No, actually, I'm guessing some number between some number like 36 and 37, and
Yeah.
because I'm using how's that called? This.
The multiplication chart.
Wait,
I can't see, it's blurry. What is that?
I don't know this in English. This is how do you describe that? It's like a tick mark with a line on the top.
Right, right. Like a tally chart. It's called a tally chart. It's when you do stuff like this.
No. Okay, draw it. It's like one. It's like a tick and a line at connect the top.
Like this?
No.
A line connects the top. Like, what are you chatting about, dude? Wait,
That
do you want to draw it? Okay, do you have a pen that you can draw on your iPad? Can you show me?
I don't have something.
I'll let you share screen. Is it possible for you to share screen and maybe you can use your finger? Or maybe you can search for it in Chinese in Google, like on one of the search engines.
Okay. Okay. So should be the thing beside one.
Oh, you're doing roots. The root, you're doing roots. Yeah. It's called roots. I know what you mean. So yeah, of course it's roots, right?
Yes.
Or however you do it, right? Do you write like that equals 3? Would you write that?
Yes.
Yeah. Square root, right? So you're doing a square root of 130 or what?
Yeah. And but it's a fraction.
That's what I'm thinking. It's a fraction, right? Yeah, it doesn't work.
Yes.
And is the fraction something like 32? Is it 32.5 or something, or 37.5?
Yes, something. 36.055551.
Yeah. So in that case, I mean, that doesn't work out. The other option, of course, is if it's something like this, you know that, right? It could be like, it doesn't have to be, does it? Oh, n times n. No, it is the same. It must be the same. It's n times n. Oh.
Yes.
Ooh, tough. Tough one. It can't be, I don't think it is. Yeah, it's not the root though, for sure. It's not the root. Hold up a second here. So you just double it. Times 6. 1, 2, 3, 4, 5. Okay. I've got an idea here. Nope. Okay, that did not work. Okay, wait. So 65 times 65. No, too big. But it should actually be, oof, I'm half in it. That doesn't work. Double? How many would like 10 times 10 be? 60. 10 times 10 would be 120. Okay. Hmm. Hmm. Tough. Hmm. Yeah, 37 times 37 doesn't work, dude. Boy. How does this work? Okay, so we're forgetting something because like you have to visualize it, right? You have to visualize that with every increase, maybe there's like some extra number, like the formula equals like n times n equals n to n. I think it's to be something like a formula, right? N times n equals 2n plus a number. I legit think that is to be like that. Because so far, when we look at this one, we've got n times n equals 2n times, and that one's times n plus 1. For example, it's currently like n plus 1. But then that would just be 3n plus 1, right? But that doesn't make sense, does it? That can't be what it is. 3n plus 1. 2, 4, 6. No, so that's not it. So it can't be that. 2n times, times n plus 1. Oh boy. No way. Does that work?
No, because the only possible answer for this formula is n equals 0. Because yes.
Why?
Well,
Oh, it can only be 0 for what it should equal, you mean?
wait,
No, wait.
no.
So if this is 2, if n equals 2, then it's 2 times 2 equals 4 times n plus 1 equals 3. Hmm. I think this is wrong, but the point is we could maybe work out a formula that works like that. So, because we're looking at 100, we're looking at 1300, but that's how many matches it equals, right? But that still doesn't give us 1300. We need, like, we need this to equal 1300. And then that can't be right. So that's not n. Sugar. That's 5 times 5. That's not working it out. Yeah. Mm. 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 Whoa, this is tough. I like this. Mm. It's too low. Too high. Mm. I got it. I know what it is, dude.
No way.
I know the answer, bro. Yeah, I got it. I got it. This formula works. I believe the answer is 25 times 25. Now you're saying, why is it that 25 times 25 only equals 625, right? But check out. I could be wrong here. I mean, at least this is what I got here. This is, okay, so this is stupid. I think I'm probably wrong. But this is what I got from this. If it's 25 times 25, then it would be 25 times 2 equals 50 times 26. That happens to equal 1,300. Right?
Bro.
Now, the reason I got that, 25 plus 1. So the reason I got that is because, like, for example, you can't do 25 times 25 to show how many there are. Like 3 times 3 doesn't equal 12, right? you know,
Right.
3 times 3 doesn't equal, it would equal 9. It shouldn't equal 24. So we know that this doesn't use square roots because the answers are not related. This should be 9, but instead it's 24. So we need a method of transforming this into 24. What's the method of transforming 3 times 3 into 24? There's a formula, right?
Right.
Turns out that formula, for me at least, is wherever n is, n times n equals 2n times n plus 1. That seems to work with every single number so far that I put in, I think, right? For example, let's check it if it's 12. Let's go back. So we know we got 4 should equal 40, right? 4 times 4 should equal 40. Well, if we follow that here, 4 times 4, it should equal 40. So 2 times 4 is 8. And times 4 plus 1. 4 plus 1. 4 plus 1 happens to be 5. 8 times 5 is 40. And that's the correct answer. Let's try it with 3 times 3. Just to prove that it's working with every number. 3 times 3 would equal 3 times 2 is 6 times 3 plus 1 is 4. So the answer in this case should be 6, 12, 18, 24. If it is 24, then we can see that the formula is solid. Yeah, times 3 is 24.
Well, I understand this method, but if you really tried to solve this formula without adding any actual numbers, it's like n squared equals 2n squared plus 2n. So
right, makes no sense, right? Yeah.
Yeah.
Yeah. So actually, this is not an equation. This is not an equation. They're not equal. So this is actually I think this is a function. Yeah. I think this is a function of like, this would be known as something called a function, where there's like a input, a process, and an output. Is it wrong? No, I mean, I could be wrong. I this is just what I'm thinking. So the input would be n. The process would actually be, I guess, it would be this one, right? 2n, or maybe. Yeah. And then the output is this. It would give it. But I mean, yeah, they don't balance. That's true. Yeah, I don't think it's a formula as such. It's not a formula. It's not like an algebraic formula equation. A function. What's a function in Chinese? Let me see if that works. Okay, I wonder what the answer is though, because I'm probably wrong, right? Do you want me to check the answer and I won't tell you if it's wrong? I mean, I won't tell you if it's the right answer, I'll tell you. If it's the wrong answer, I'll let you keep trying. You want to try?
Okay.
All right, let me double check then. But yeah, like in mathematics, a relationship or expression involving one or more variables is a relationship. A relationship. So the relationship of this is that this is the relationship. If we put any number into here, whatever the n equals, it's going to turn it into that. So this is the function. This is actually the function. Yeah, this here, 2n plus 1. Yeah, I would say like that. All right, let me try the answer then. So I'm going to turn the screen sharing off real quick. And then we'll do it. Dude, this is so fun. This is such a fun lesson to do this together. Okay, do you not have an answer then? You still don't know the answer, right?
No.
Okay. Build a magic square. Okay. How many for and 1300 matches? Okay. Okay. I think it's called the magic square. No. No, not magic square. No. Oh, tough. Okay. Math problems in solving matches. Okay. Yeah. There we go. I'm going to put n equals. It's tough to find. No, there's not very many good. Equals 12, 4 times 4. Wait, no, 3 times 3 equals 23, right? 2 times 2 equals 12, right? 3 times 3 equals 24. Hmm. It's not quite find. I can't find it. Oh wait, maybe this is it. No, this is not the answer. What do you think it is then, William? Where are you going with your head so far? What have you got? It can't be something to do with square roots, right? There's no way it can be square roots.
Yes.
So what do you think it is? I'm still looking. Hmm. What are we thinking here, William? Still not got it.
No.
Hmm. Well, I mean, you could keep going with. Have you tried drawing out a 5 times 5 table?
Yes.
So let me just check what 5 times 5 table would be. It would be 10. Look. Is it 60?
Yes.
Okay. Would you like to do a 6 times table? A 6 times 6? I'll tell you how much that could be as well.
6 times 6 should be 12 times.
Be 84, right?
Yes.
Yeah. So then this is true. This calculation is true. So the answer should be 25, right?
Yes.
Can you see that?
Yes.
Did you know how to do that though?
Yes.
All right, cool. I'm trying to think. I could make it fun for you. I could extend what your dad. Sorry, I'm not sharing screen right now, but let me just show you. The way you could make it fun for your dad, you could give him one back. You could give him a riddle back. So we know that this is the correct formula for this. This is how we work out what it is. You could give your dad this. And you could say, what would this be? This would be, let's say 2. 2 times 2 would be 2, 4, 2, 4, 6. 6 times 7. Except it doesn't work, right? Because, I mean, at this point, it doesn't work with actual pictures. Like, I mean, the visualization part wouldn't work. It would just be a random formula. Your dad would have to solve the actual formula. So this would equal, in this formula, this 2 times 2 grid would equal, it should equal 42, right? So you could ask him, you know, you could tell him, you know, this. Do you know the answer for that as well? It would be, it would also be this.
Yes.
Yeah, so it'd be like the same answer. Yeah. All right. So that was fun. I really enjoyed that actually. Why this? I mean, I think the way I learned from this is that you have to look at these numbers and you'll see a pattern, right? Like at first I was trying to see the pattern here and it, you know, it wasn't working out so well. And if we break this down into, I think what helped me was breaking this down into, what do they call it? Square, is it root multiplication? Like basic multiplication. Like they gave you this, but they only gave you the answer here. So you need to work out what this is, you know? And it turns out this is 4 times 3. There's a pattern here. So because we've got this regularity, you can see that there must be a formula that goes into it. Yeah. And to get from this to this is a formula. 3 times 2. You can just see it's just times 2. That was fun. Dude, thank you so much. That really worked my brain. Yeah. Hopefully that's the right answer with your dad. Because I mean, if it's not, I'm gonna be so sad. I could be wrong. All right. We're cool. That was fun. Thank you.